Hi guys, today I will be solving problem number 19 from chapter 17. The problem reads, a bass clarinet can be modeled as a 120 centimeter long open closed tube. A bass clarinet player starts playing in a 120 Celsius degree room, but soon the air inside the clarinet warms to where the speed of sound is 352 meters per second. Does the fundamental frequency increase or decrease? If so, by how much? So here we have a clarinet player that starts playing his instrument, and initially the temperature in the room is 20 degrees Celsius, and we have a specific speed for the sound. But as he keeps blowing air in and it warms the instrument, the speed of sound increases, and the frequency becomes 352 meters per second. That is the speed of sound after air is heated up. So what we want to figure out is the fundamental frequency at the beginning and at the end. So we want to find the difference. The fundamental frequency formula is f of m is equal to m over velocity divided by 4L. And our m is 1 in this case. So our fundamental frequency is the velocity of sound over 4 times the length. So given by the problem, we know that the length of the clarinet is 1.2 meters. The initial temperature given is 20 centimeters Celsius. The final velocity of sound is 352 meters per second, and we are missing the initial velocity. To find the initial velocity, this right here helps us find the speed of sound at specific temperatures. So here we have 331 plus 0.6 times the specific temperature, which in this case is 20 degrees Celsius, will give us a 343 meters per second, which is the literature value for sound. So we could have just said that it's 343 because it's in standard conditions, which means that it's at 20 degrees Celsius. So what we do to solve for the fundamental frequency, we simply take the change of velocity of speed here. So we have the fundamental frequency equal to the final velocity, which is 352, minus the initial velocity of sound, which is 343, divided by 4 times the 1.2 meters, which is the length of the clarinet. And once we solve for this, we find that the change in the fundamental frequency is 1.9 hertz. And we can conclude that the fundamental frequency increases by 1.9 hertz.